So today we're looking at the turn signal slash hazard, also called multifunction switch on an 88 Bronco. I've pulled the steering wheel, and this is what's behind it. So the turn signal lever is over here. We wiggle it, this piece moves, and I'll show you why this is a bad design. So we have a couple little ears right here, little pointed arrow looking thing right there and right there. That is what retains this in the left and right position. So if I signal to the right, it hangs on that ear. I think you can see that. And if I want to cancel the turn, I let go, or I push it a little bit to the left, and then it is supposed to spring back to center. Those points are ultimately what cause this thing to lock into position in the left and right positions and spring back to center. The problem is it doesn't work. And we took the original out of here, which had problems. And this is actually a complete replacement unit. It's brand new, and it still doesn't work. And the problem is the new one is built with a little bit thinner plastic than the original. So its ability to return to the center position is not as good as the OEM. And there's nothing you can do about it. If you pull one of these from a junkyard, the plastic will be worn out and cracked just like the one that came out of here. And if you buy an aftermarket unit, they're all shitty. And that's all there is to it. So what's happening is you can signal, it does signal, but it'll stay in that position. And if you want to turn your turn signals off to cancel the turn, you should just boop it a little bit and it should return itself to centered. The problem is it doesn't. It sticks anywhere in here and it doesn't actually center itself. That's a huge problem because on this vehicle, the turn signal, the hazards, and the brake lights are all the same bulb. You have your tail lights that are the dimmer bulb, and then you have all of the rest of those that all go through a single bulb in each one of the assemblies. So if I'm turning to the right, the right rear bright light flashes and the left rear bright light does nothing. If I'm braking, the left rear light becomes my brake light, and I don't have a brake light on the right rear corner because it's flashing. Those bulbs are shared. So if this thing ends up somewhere at an in-between state, what can happen is you're not turn signaling and you also don't have brake lights on one corner or the other, or hey, maybe both. And I'll show you why. There's no fancy electronics going on here. All the electrical connections are made through these shitty bent wires and these shitty, slightly greased contacts. And as I'm rocking this back and forth, it makes and breaks connections in different patterns. So if we end up at an in-between state, we can end up at a point where these are not making good connections with these pads, and then we don't have brake lights, and that's a dangerous situation to be in. We could not have brakes, we could not have hazards, because the hazards also run through this mess. So we're going to throw all of this away. We're not buying aftermarket units, we're going to throw it all away, and I'm going to build a multifunction switch from scratch. So let's get started. So we don't get to throw away the entire thing. We can toss the hazard switch. We're not going to need that anymore. All of this wiring goes away. This wire has to stay. This is ignition power. You can see it running to the ignition cylinder over here. And these two wires and contacts up here are going to have to stay. They run to the buttons on the steering wheel, which include the horn. But the rest of this is going to go. The front plate actually stays as well as the back plate because it ties into the turn signal lever. Even though we're not going to use it for turning anymore, this on this vehicle, if you push it back, is your steering wheel lock release. So we do have to keep the lever just as a steering wheel release. Here's a little look underneath the dash. That light gray plug, the giant one right center of the screen, is the plug that goes to all the stuff in the steering column. So that's what we've chopped a few wires out of, and we're going to fish those back out of the steering column and bring them down here in the floorboard area. And there's a look at the cleaned up internals. We have 12.5 volts on white with red. So white with red is hot. Now, it says that is the hazard flasher. And it probably is. Let's see if we can figure out which one's the brake. Look at that. That's the brake switch. Okay. Solid green is brake. Aha! We've got a hot black wire. That's interesting. Okay, yeah, so I have broken my test light. Don't have one of those at the moment. But I have a couple of fatty 100 ohm resistors that are actually wired in parallel. Gives me 50 ohms. That's probably suitable to simulate some kind of a bulb for purposes of a flasher module. And I'm going to test again just to make sure. Was it hot? Was it black? Yeah, we get 11 volts on that one. We're going to run it through the resistor pack and to find out if it flashes. You hear what I hear? That's a flasher module. This is for testing purposes, so I have a known 12 volt wire. Here, I'll turn the meter on. You can see we got nothing right now, but this is on ignition hot. So when I turn ignition on, there you go, we got power. And basically I'm going to bridge this to these exposed wires and figure out which one's which by looking at which lamp illuminates, because I got 4 wires left and they should go to 4 lamps. I'm going to twist them together. Yep, that'll work. Okay, and let's go check and see if we got any lights. Left rear, no. Right rear, yes. Okay. So confirmed, right rear is red. And I'm going to do the exact same thing for the others to figure out which one's which. All right, here's the test setup. We have our black wire running to ground like usual. We have our red wire. There's nothing going on here. I just needed a longer wire. Red wire running to pin 6 on the Arduino. Not bad, right? So we got a dim mode and a bright mode. Now, to me, if I were driving the vehicle, I'm not too sure I'd see the difference between the dim mode and the bright mode. So I can tweak that pulse width modulated value. Instead of 128, maybe I'll send it, I don't know, 80 or something to indicate that I want it to be even dimmer. Let's try that real quick. Here's our new program. And the dimmer mode is, in fact, quite a bit dimmer. I happen to like that. I think that looks pretty good. All right, there's a fair amount of jank going on in my circuit here. Mostly my test lamp. I did have a real test lamp, but I backed over it and broke it. So we're going with some wires soldered and taped to a bulb ripped out of an 86 Samurai, because that seems like a good idea. So here's the circuit. We're using pin number 2 on the Arduino. It comes over here, goes through that 100 ohm resistor, goes to the base pin on the BJT. I won't bore you with the rest. MOSFET's right here, and then the middle pin on the MOSFET goes out to the bulb, and then from the bulb we come back to the ground bar. So I should be able to switch pin 2 on and off. That runs through all that mess, and it should switch this light on and off. And it should switch it in sync with the LED. We'll have off is off, dim is off, and then when it goes bright like that, the bulb will come on. Let me flip the switch on my 12 volt. So we're off, we're still off, and we're on. Bingo. So we've got one working circuit. I just got to wire up 4 of those. I think this is all of the connections that are made between the Arduino and the circuit board. The rest of these go out to wires that ultimately end up outside the case. I was going to make the case from scratch But then I realized, why let a good barbecue part go to waste? Look at the fit on that. It's beautiful. Got a few more wires run. That is the LED output that flashes the little lights inside the switches. There we go, all closed up. Don't look too bad. And I've left a port open in the front where we can program and test the Arduino without opening the box. All right. I'm going to wait until tomorrow to vacuum all this, but it's all tucked away. There's our switches. Time to give you a little demo. Key on. Ignition on. Isn't that shit cool? Ready? Oh yeah. Yep. There we go, blinking away. If we hit right instead, it cancels left, switches to right. We can cancel it. We can activate hazard mode. Oh, it's beautiful. Just beautiful. With conventional turn signals that share a bulb, you cannot activate a turn signal while you're in hazard mode. So we have that implemented. Cancel hazard. Back to turn signals. And of course, all of this works with the brakes. And the turn signal saga is over.